Hey, Chemsters, this is Mrs. Vanderlei bringing you Chapter 8, really 8.1 Nomenclature for Ethers. But as we always start off, we have an intro. So you may have heard about ethers. They are typically associated with general anesthetic, like anesthesia, puts you out, if you will. All right. Also, they're also a common ingredient in starter fluids for car engines. But a not well-known fact, actually, the chemical, get this, tetrahydrocannabinol, THC. Do you see that? Tetrahydro. All right, then this cannabinol, all right, is the active ingredient in marijuana. All right, so I'm not trying to tell you anything about how to make it. No, we're not going to do that. But just it's these ethers are out there, whether you've heard of it or not. So it says identify the functional groups, all right, found in this THC. Well, the first one I want to show you is right here, and that was from chapter 3. That's an aromatic, okay? Another one that we just learned is right here, and that's an alcohol. So if you put them together, you might call that a phenol. All right, but there's one more out there. Well, we can call that an alkene, but I didn't include that. Is an ether. So the ether is right here, okay? That is your ether group, okay? So what is an ether? Well, let's find out. Okay. So a common are compounds in which two organic groups are connected to a single oxygen atom. They're single bonded. The general formula for ethers is ROR, where you have two different carbon groups or identical carbon groups. They can be like regular straight chain carbons, or they could be the aromatic groups, like a benzene or something. And in common anesthetic there, that knocks you out, they're both ethyl groups. So that you may have heard of back in the Civil War times, all right, knocking people out to put them to sleep before surgery. This is what they were using. All right, so this is Mrs. Vanderwally's way to remember what an ether looks like. Those are my ether bunnies. All right, notice how the ether bunny has this oxygen in between the two ether bunnies. All right, that's my ether bunny. So I know it's really bad, but this is like my carbon, single bond to oxygen, single bond to carbon, my ether. Okay, so anyway, a little bit of chemistry humor for you. All right, so how do we do this? Ethers are names by giving the name of each carbon group, each alkyl or aryl group, all right, in alphabetical order, followed by the word ether. So let's see how this works. So the first thing is to figure out what's on each side. So over here, I have a 2-carbon group, which is an ethyl group. Over here, I have a 1-carbon group, which is a methyl group. So what comes first is ethyl, because that's alphabetical. So it becomes, ready, ethyl methyl ether. I know, it sounds like we're having a lisp, doesn't it? All right, but that's ethyl methyl ether. So ethers are named, our names are given the name of each alkyl group in alphabetical order, followed by the word ether. All right, so what about the next one? I have an ether group and I have an ether group. Oh, this is just like what I showed you up here. So instead of saying ethyl ethyl ether, they just say, all right, we have two of the same group, so we're going to call it diethyl ether. And don't forget, we can also have these aromatic groups. All right, so here is a phenyl and here is a phenyl. Remember, they're not benzene rings. Remember how we call them phenyl if they are like part of a side chain. So it's diphenyl ether. All right, now we have something else coming up. Those are simple structures that the oxygen is bonded in each of these cases on the first carbon. It's not in a middle carbon. So we have to do something else if the oxygen's on a middle carbon there, okay? All right, so ethers with a more complex structure, it may be necessary to name this group as an alkoxy group. In the IUPAC system, the smaller alkyl group is named as a substituent. All right, so notice at first, so these are not the same. And what else do you notice? That this oxygen is not on an end carbon, but on a middle carbon. So what I need to do is I'm going to make this as it's smaller. I have one group or one carbon versus 5. So I'm going to make this as a substituent. I'll show you how to do that. But next thing I have to do is I have to name, which carbons these are. So the OH group is off of the second carbon. So this becomes 2-methoxy. That's how you name this as a substituent, is something oxy pentane. So one carbon meth oxy. It's on a pentane, but it's on the second carbon of the pentane. All right. What about this one over here? Well, what do you notice? This is an alcohol group. This is, whoops, this is my ether group. Okay, so now what? What do you remember takes priority? The alcohol takes the priority. So where is my ether? It's on the second carbon, because remember how alcohol would have to be on the first carbon? So that's number 1. So the ether is on the second. Well, how many carbons are hanging off of it? 1. So it becomes a 2-methoxy cyclohexanol. You can also use the methoxy cyclohexanol. All right. Oops, not M. Mrs. Vanderwall. Holy cow. Make that an O. Ortho. Ortho methoxy cyclohexanol. All right. So it's orthometapara. Got it. So what about this one over here? All right. I see 3 different ether groups. So I'm going to call this 1,3,5-trimethoxybenzene. Now, why is it a phenyl group? Well, because the benzene is the main thing. It's not a side chain. The methoxy groups are your side chains. But I want to show you something real quick, okay? Let's go back and look at this first one again. What if the O8, or the OC group is hanging off the first carbon? Is this going to be 1-methoxypentane? No, it's not. This is just like what we did before. Because that the oxygen is on the first carbon of each, it's just that, like what we did, methyl pentyl ether. All right. So keep in mind, if it's on the end carbons, then it's just like something ether. If it is not on an end carbon, if it's in an interior carbon, that's when you have to decide what's your smallest chain, all right, your smallest carbon group, and that becomes a substituent, okay? Hopefully that makes some sense. Let's go on the next page. Okay, so is this as easy as, like, something ether? No. First of all, this is a branch, and second of all, this is off of the second carbon. All right, so no, that doesn't really work. So let's see here. I have a 4-carbon chain. I have a methyl group off of here, and I have an ethyl group here. So which is my smaller chain, or my smaller R group? Is it 4 or is it 2? Well, it's 2, isn't it? So now this ethoxy has to be a chain. And what comes first, eth or meth? Eth comes first. So I'll name it first. It becomes 2-ethoxy 3-methylbutane. Okay, does that make sense? So here's my butane. So this becomes a branch. So that's your 2-ethoxy. Your methyl group's over here. And so it's 2-ethoxy 3-methylbutane. Now what about this next one? I went ahead and I kind of made it look like this. All right. Why would I do that? Is it like a 2-methyl methoxy? No. What's my longest chain? 3 is my longest chain. Do you see that? That counts. This is not a branch. This carbon right here is not a branch. This is part of the longest chain. So you have a propane going. So you have a 2-methoxy propane. Okay, again, this is part of my longest branch. So it becomes 2-methoxypropane. Let's look at the next one. Now look at number 3. Do you think that we're going to have to do like something ethoxy or methoxy or propoxy or anything like that? And the answer is no, you don't. Because This oxygen is on like a first carbon. There isn't really a first carbon here, but it kind of is. And this right here is a first carbon. Okay, so now I gotta figure out which is alphabetical. Well, this is a phenyl group. This is a propyl group. Well, what comes first alphabetically? PHEN or PROP? PHEN does. So it becomes a phenyl propyl ether. Okay, let's look at number 4. Well, this looks kind of like a mess. All right. So notice that this is on the first carbon over here, and it's kind of on the first carbon of the cyclohexane here too. But what else happens? That I have a branch off of my cyclohexane, don't I? So I have 2 branches off of the cyclohexane. I have a methyl group and I have a ethoxy group. Well, which one comes first alphabetically? M or E? E does. All right, and they're both on the same carbon, so I had to let them know that. So it becomes 1 ethoxy, 1 methyl cyclohexane. Okay. All right, see the hexagons? I'm still using them, aren't I? Lots and lots of hexagons. So write the structural formula for each of these. Dicyclopropyl ether and 2-methoxyoctane. Why don't you go ahead and do those, pause this, and when you're done, come back. All right, welcome back. This is what I did. Hey, they're not hexagons. It looks, I don't know, like a Star Wars something, doesn't it? One of the little flyers, I don't know. But that's my dicyclopropyl ether. And then my 2-methoxyoctane looks like this. Here's my octane, and off of the second carbon, I have a methoxy. All right. So that concludes ether nomenclature. I hope this helps. Don't wait to be great. We'll see you next time. Bye-bye.